Hello everyone, welcome to Pepcoding. Today we are here to solve a question merge-two-sorted linked list. Okay, so in this question we are given with two sorted linked lists. One is this and the second one is this, and in the output we have one single linked list, that is merger of both the linked lists. Okay, so what we have here, we have -1, then here we have -1. The output linked list is also sorted. So after that we again compare that, and after that 0 is smaller, so 0 is here. After that 1, then 1 is here. After that 2, then 2 is here. These two are same, so 6. After that 7. After that 15. After that 17. After that 24. And after that 25. So this is the output. Okay, so let's erase this and let's go and look at the constraint what we have. Okay, so we are here. So actually, where is the constraint? It is down here. Okay, so the constraint is that the size of the linked list vary from 0 to 10 to the power 6. What it means? It means that we have to solve this question in the complexity of O of n. Let me tell you why. Okay, we are here. Just suppose the size of this is m, the size of this is n. Okay, if we solve this question in the complexity of n square, what will happen? Just suppose this size is 10 to the power 6. Its size is also 10 to the power 6. So if you solve in n square, what it means? It means m cross n maybe. So 10 to the power 6 into 10 to the power 6, it will be 10 to the power 12. What it means? It means you have crossed the constraint. So this won't pass the test cases. This will get stuck. Okay. And you can use the m plus n complexity. Like if it is 10 to the power 6 plus 10 to the power 6, what it means? It means twice of 10 to the power 6. So this can easily be passed. Okay. So we can use this, but not this. Okay, so let's erase this and get on the board. On the board, I have already written the test cases for us. So let's go there. Let me erase this here first. Okay, so this is done. Almost done. Yeah. Now we are here on the board. This is the two given linked list. Just suppose this is the two given linked list. So first of all, what we have to do, we have to make a dummy node. Okay, so this is the dummy node. Okay, now what will happen? This is the linked list 1 and this is the linked list 2. These both have head here. Okay, so we don't mess up with the head, because what will happen if we lose the head? Just suppose if we by mistake if we lose the head, it means the complete linked list is gone. Okay, so we won't mess up with the head. Instead of that, we will use iterator C1 for L1 and C2 for L2. Okay, so what will happen now? We'll compare C1 and C2. Before that, we will make a previous node also, that will be on dummy here. Now what we are going to do? We are going to compare C1 and C2, and whichever node is smaller, what we will do? We will connect it with the previous one. Okay, so we compare, this is -1, this is certainly smaller. Okay, so the link will be created from previous here to here. Okay, when it is done, what will happen? The C2 will move forward and the previous will also move forward. Okay, again the comparison goes in C1 and C2. Again C2 wins, so again the link will be built here. C2 again will move and the previous will again move. Now again comparison, so C1 wins this time. What will happen? This link will be broken, and this time in the next of previous, this C1 will be attached. Okay, and this time C1 will move forward because C1 win this fight. So C1 is here and previous also moves to its next, so previous is here. Again comparison, so C1 wins again. What will happen now? This link will be created, C1 again moves forward and previous again moves forward. Okay, it is here. Again comparison, so these two are same, so we can take any of them. So just suppose we are taking C2, so we have to break this link and then we have to create this link. Okay, and after that C2 will move forward. C2 is here and previous is here. Again C1 and C2 is getting compared, and this time C1 wins. So this link will be created. Before that this should be raised. Okay, this is raised now. And what will happen? C1 will move forward and previous will move forward too. Now again C1 C2 compared, C1 wins. So this link will be created. C1 moves forward and previous also moves forward. Okay, again C1 and C2 compared, C1 again wins. Again the same thing, this link will be created and C1 moves forward and the previous also moves forward. Oh, we left our P here. Okay, so it is also here. Okay, again on comparison C2 wins this time. So what will happen? This link will be created and this link will be raised. Okay, this time C2 will move forward. So this is C2, it will move forward and previous will also move forward. So now what is it? Here we can see C2 is null now, like this link is completely merged with the above link. Okay, and this part of link is left. So for now what we have to do, we have both the link sorted in form. Okay, so now we can simply attach this C1 with previous to get this complete list in one form, one list. Okay, and in the sorted form also. So there is a condition: if any of the list reach to the null, what will happen? The non-empty list will get attached to the previous to get the result. Okay, so we will code this method. Like after this, what will happen? We just simply connect this with C1 and this is done. We have this complete linked list merged. Okay, now what is going to happen? Just suppose we have two we can say exception cases, exception not, just suppose if we have two linked lists, just one is this and just suppose the second linked list is null. What it means? It means we just have one linked list and the second is null. If we merge both of them, what will happen? We will just get this as a result. And the second case is we have both the linked lists as null. So what it means? It means we can return any of them because both are null, so we need the result as null. So if we return any of them, it doesn't matter. Okay, so now let's go on later and write them. So we are here. Okay, so now let's go and see. We have to write the code here. So first of all, we'll handle that case if the linked list is null. So if L1 is equals to null pointer or L2 is equals to null pointer. If any of them is null, it means we will return L1 is not equals to null pointer. So what we'll do? We will return L1, else we will return L2. Okay, this is done. This will take care of that case. After that, what we have to do? First of all, we have to create a dummy node. Okay, list node dummy equals to new node minus one. New, okay, new list node minus one. Okay, so one dummy node is created. Now what we have to do? We have to create a previous node. So for that, list node the previous one, which will be on dummy first. Okay, this is also done. Now we need to create the iterator for list 1 and list 2. Okay, so list node, we can call it C1 for L1. Okay, and we can do the same list node C2 for L2. Okay, this is also done. After that, we need to start the comparison. Okay, so we will run a while loop here. So until any of them became null. Okay, so what will happen? Until the C1 is not equals to null, C1 is not equals to null, and C2 is not equals to null, what will happen? We will run this loop. Okay, definitely we are going to run this loop until one of them became null. Okay, this is done. Now what will happen inside this loop? The comparison. Okay, if the value of C1 is less than the value of C2, what will happen? We will connect C1 to the next of previous. So previous dot next will be C1, and C1 will sorry, C1 will also move forward. So C1 next equals to sorry, C1 equals to C1 next. Okay, else what will happen? Else we will go to the C2, then in the next of previous, C2 will be stored and C2 will also move forward. C2 equals to C2 next. Okay, this part is done. After doing this, what we have to do? We have to move forward the previous one. So previous equals to previous next. Okay, this is also done. When we come out of this loop, what it means? It means at least one of the linked list is completely merged with the upper linked list, and we have a part left, and that part is the non-empty subset. Okay, so what we are going to do now? We are simply going to check which one is non-empty and we'll connect it to the previous one. It is very simple. Okay, so previous next will be equals to the non-empty one. So we will check if L1 is not equals to null. So what will happen? We will simply add L1. Okay, we will add L1, else we will add L2, or not actually L. We are using C, the iterator. Okay, so this is the work. Using this statement, the non-empty linked list will be attached to the previous one. So the complete linked list is merged now. After that, we will return something from here. Na? So while returning, let me tell you something. We are starting with this dummy, but we don't have to include this dummy in the resultant output. So we have to return the next of the dummy. Can you understand that? Because our linked list start from this point. Okay. So we will return the next of the dummy. Next. Okay, so this is done. Now let's go and run this code and see. So we have some error here. Let me see. Okay, dummy previous, let me see, line number 17. Okay, we have a typing mistake here, the null pointer. Okay, so this is also done. This is good, seems good. Okay, null pointer. Now let's run it again. Okay, now we have some here. What it is all value required as left offering of assignment. Okay, I think let me see. Okay, we have merged equals to here. Now let's run it. So it is accepted. Now let's submit it. Correct, 10 by 10. So now let's talk about the complexity of this question, of this solution. Okay, so let's take this code to our board first. Okay, so the code is here. I'm sorry. So how many times do you think this loop will run? Just give me answers. How many times do you think really that this loop will run? Okay, so I have heard many replies that this will run till the shortest of the linked list, like whichever linked list is shortest, it will run that much of time. But it is not the truth. Let me tell you. Okay, let me tell you why. Let me erase this first, then I will give you an example that will make it more clear. Okay, here, just suppose this is the linked list 1 and this is the linked list 2. Okay, so C1 will be here, C2 will be here, previous will be here, just suppose here on dummy. Okay, this is our dummy. So it is compared. What will happen? C1 will win, this link will be generated and this link will be removed. Okay, so let me remove this link. Okay, and after that what will happen? This C1 will move forward, this C1 will move here. I'm sorry, this previous is here. Now we left our V. Okay, it is also here, so our previous is here now. After that what will happen? Again the comparison, and C2 wins this time. What will happen now? This link will be made. Okay, now what will happen? I'm sorry, this link will be removed when this link will be made. Okay, so now what is going to happen? The C2 will move forward. C2 is here now and the previous is again move to here. Again the comparison starts. What will happen? Again C2 wins, C2 will be here, previous will be here. Again C2 wins, C2 will be here, previous will be here. Again C2 wins, what will happen? C2 will be here and the previous will be here. Again comparison, so again C2 wins. Okay, this time C2 will move forward and it will become null and the previous will be here. And after that what will happen? This will be connected to this node. Okay, when it becomes null. So here we can see that in this case the longest linked list was iterated first, so the loop runs this much time. So we can simply say the loop can run m plus n time, because this is depending on the values. If the smaller values in the longest linked list, so what will happen? The longest linked list will be iterated first. Okay, so we can simply say that m plus n will be the complexity for the solution of this question. Okay, this saves time because like the rest of the linked list is just attached in one time. Okay, because that all is sorted and connected, we just have to attach the first list with this list and the complete list is attached when one linked list become empty. Okay, so certainly this is going to solve this question in O of n. Okay, so I hope you have liked the video. Please subscribe the channel and share the video. Thank you so much.